Hello, my name's Ronald Dodd and I'm making a series of videos on how to best maintain your Hornby Dublo trains. Today we'll be talking about controls and power supply. Here we have an A3 controller made by Meccano, and it's a very good unit, apart that nowadays these are very old. They're about 50 years old, and before you use one you should really get it checked by an electrician, a qualified electrician, and get it certified with a certificate that it's good for use. In order to get the best out of your railways, I recommend you purchase a multimeter. And this is the type of multimeter you need. This will measure voltage in DC and voltage in AC. It will give you continuity. It will give you amperage, that's current, and it will also tell you ohms or resistance. They're not very expensive, a few pounds, and you can buy one easily. Now, to use this, first of all we put the black lead into the common slot there, and the red lead goes into the voltage reading there, voltage slot. There is another slot is right here, and this is only used for 10 amps DC voltage readings on the scale right here. So if I want to just demonstrate how this works, we can use this controller. Right, it says on the top of the controller that the ports, the output ports here, C, are AC 15 volts. So we need to set this at AC. So AC is signified by AC volts is the little V for volts, and the squiggly line, the wavy line, it signifies AC voltage. And we have the choice of either 600 or 200. This is only 12 volts, so we're going to put it on the 200. Then we will just push them in there, and there we see we have 17.5 volts. Next, ports B tells you, says that there is it's a DC voltage of 12 volts, it says. Okay, so we need to adjust the dial to 12 volts to DC. Now DC is the straight line, so we have V for volts and the straight line here, and the choice we have is the 600 volts down. So we're looking at 12 volts, so 20 will cover that range. Okay, so that's set, and now we can put that in there, and there we have 16 volts. Next we can look at ports A. Ports A is 0 to 12 volts DC. So we're already set up on DC, and 0 to 12, so 20 is good. So we'll insert this into there. Like so, there's no reading because we have to operate the control knob. And here we go. There. I turn the control knob and we have 16 volts. It's the same wherever we place it, 16 volts. Now if I turn this to the off position and then turn it the other way to reverse, you'll see that we have a minus sign. That shows that the current is running in the other direction, and the trainer would then be running in reverse. These old controllers work by resistance in there, so the more you turn the handle, the less resistance and the faster the train goes. But the voltage always remains about the same. Okay, next we can demonstrate continuity. Continuity is here. There's a little buzzer in this. In most meters they have a little buzzer, so when you set the dial to the continuity and then touch it, I think you can just about hear it on this one. Let's put that there. When the circuit is open, one is shown on the gauge. Close the circuit and a 0 comes up. So 1 is open and 0 is closed. Open, closed. Now here we have a piece of track. Now if I put one probe this side, one probe that side, you'll see that we have continuity between the two outside rails. Yet if I put one on the middle rail, there's no continuity, which is how it should be. This is very good for checking for short circuits on your rails or other problems, just that you have power everywhere and it's working right. But one common mistake is to leave a train on and then try and check it, because if you leave the locomotive on there and then check it, it'll show you have continuity when really you don't have continuity. So you must always remember when you're checking your track to remove your locomotives. Next, we can do resistance. Now, resistance is ohms. Is this symbol here means ohms. Now I know from experience that the setting I need to test this armature is 200, in the 200 range. Now if you look at an armature, you do this without removing it from the locomotive best, or else you'll need to remag the magnet. You need to remove the carbon brushes, and then you can reach inside with your probes and test it. And this is how it's done. There's 3 segments, 1, 2, 3, that control the 3 windings around the motor. Now you place one probe on any 2 of the segments, or the 2 adjoining segments, like so, and then take the reading. That's about 4.8 or something like that. Then you rotate onto the next pair of segments, like so, and see what the reading is there. And there we have about 5.4, about the same. And then turn to the next pair of segments, and there we have about the same again. That's showing that the resistance is the same through all the windings, all 3 windings. And while we're checking it, we could also turn this back to continuity and then just check that the coils are not going to ground. So I touch this on the gear wheel at the bottom here, and then just check that there's no continuity between the three segments on the commutator and the metal parts. So that's a good armature. It should work okay. Another function of this is to check the amperage, how much the current, how much power this is going to be used when you're running your locos. So to do that, you need to set this on the 10 amps right there. Then you unplug the red lead and plug it in to the 10 amps at the bottom here. Okay. Right, I have a local ready here, and that little bit of track is wired up, and my controller. There, you can see it's working fine. Now, in order for the meter to work, the power has to go through the meter itself in series. That means you need to disconnect one of the wires from the track, put it on one side of the one lead from the meter, and the other meter needs to connect up to the track there. And then if you turn the power on, you see we have a meter there. It's about 4.5. Now the less load, if I lift this slightly, you'll see that the amperage should go down. There we have 3.1, very little pressure with about 3.3 amps. And if I press down on the same little bit, you see it goes up to about 5 or more. So that signifies how much power you're using. These locos should not be running at anything over 0.65 amps, or else you could burn them out or damage the windings. I'd like to just show you the difference now between the modern controller and the old one, the original Meccano controller. We saw when I tested the volts on the Meccano controller that it was always at 13 volts or thereabouts, no matter what the position the handle was. With the modern controllers, they control the speed by varying the voltage. So I need to set this, sorry, I need to set this at, you have to put it back to voltage, so we change the wire back over and we put it to DC 20 volts again. Now I'm going to put this onto the track, one onto the middle, one onto the outside, and then turn the controller on. Now you can see there's 3 volts, and as I rotate the handle, it increases the voltage, which increases the speed. And as I explained before, with the other type of the old controllers, they used a resistance to slow the train down. So I think that's all we need to know for just now. Hope you enjoyed this video. Thank you very much.